Today is Monday, November 30th, 2020, and our I Can for today says, I can explain factors, multiples, prime, and composite. So we're going to figure out what all four of these words mean today. Let's start with an example. I'm going to start with my number 12. I'm going to put 12 in the sun over here. 12 is the number that we're going to be looking for the factors of 12. Now to do this, we're going to take and put a whole series of numbers into a rainbow. The rainbow is going to start, I'm going to go up to the line that the 12 is on. I'm going to leave this blank because I'm going to write something up here in a minute. So leave that line. But I'm going to start my rainbow with 1 times 12 because 1 times 12 gives me 12. Now I'm going to go in order. Can I do 2 times any other number? 2 times what would give me 12? 2 times 6. 2 times 6 equals 12. All right, so I did 1, I did 2. Let's try 3. 3 times something gives me 12. 3 times 4. So I have 1, 2, 3, and then 4 is already in my rainbow. So guys, we're done. I'm going to put a cloud around these numbers, and these numbers are what we call the factors of 12. The number in the clouds, all of these numbers are the factors of 12. Now, I'm going to count. I'm going to say 1, 2, 3, 4, 5, 6. There are 6 factors. I said 6 factors because there were 6 numbers down here, right? Sometimes people might ask you, how many pairs, how many factor pairs are there? Well, there was 1 times 12, that's 1. There's 2 times 6, that's 2. And there's 3 times 4, that's 3. So I would say there are 3 factor pairs. Sometimes when I'm thinking about factor pairs, I like to think about the stripes. How many stripes are in my rainbow? 1, 2, 3. So there are 3 factor pairs. So I know that the number 12 has these factors, 6 factors. There are 3 factor pairs. And so I've identified the factors. I want to find multiples. When I think about a multiple are like the stars in the sky. They go on forever. We don't know exactly how many there are. So multiples, we're going to list up here next to the sun, and they're going to be like the stars in the sky or like the planets. I'm going to make 6 circles, but I'm going to put a dot, dot, dot at the end because multiples go on forever. Factors, there's a set number that are in this cloud down here. But multiples go on forever. You could list multiples all the way until dinner time if you wanted to. So let's skip count. For multiples, I just skip count, but whatever this number is. So 12, 24, 36, 48, 60, 72, 84, and so on and so on and so on. These are the multiples of 12. These are the factors of 12. Factors are the numbers we can multiply together. There's a set number of factors. Multiples go on forever. So I've got some new highlighters from Miss Allen here. She thought we were in need of some new ones. I'm going to highlight where I have multiples go on forever. Factors are right here in the cloud. There is a set number of factors. If you have an older brother or sister and they say, hey, I can find another factor, They can't. If you know all these numbers, you know all of the factors for 12. All right, let's try another one. I'm going to come down just a little bit. I'm going to make a new sum. And this time it's going to be for the number 10. I'm going to skip 2 lines, then I'm going to put the number 10 in my sum. All right, so I have my number 10. I'm going to start by making a rainbow for the number 10. And I always start in the same place. I'm going to start with my rainbow, coming up to the line, but not going over it. My first factor pair is always 1 times the number. 1 times 10 gives me 10. Let's go in order. 2 times what gives me 10? 2 times 5. 2 times 5 is 10. All right, what about 3? 3 times 3 is 9. 3 times 4 is 12, so no 3s. What about 4? 4 times 2 is 8. 4 times 3 is 12. No 4. What about 5? 5 is already in my cloud. I'm going to circle these, and these numbers are the factors of 10. The numbers in the clouds are the factors. There are a set number of factors. There are no more and no less. So how many factors do we have for 10? 1, 2, 3, 4. So we would write there are 4 factors. Well, what if I asked you how many factor pairs we had? How many factor pairs are there? Well, remember, when I'm counting pairs, I'm going to count the stripes. 1, 2. So I would say there are 2 factor pairs. Good. So I know the factors. That's the number in my clouds. Now I need to list the multiples. I'm going to make 6 circles, but I'm going to put a dot, dot, dot at the end, because what do we know about multiples? Well, multiples go on forever. They're just like the stars in the sky. We don't know how many there are, but they go on forever. I'm guessing that we all like to skip count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and on forever and ever and ever. Multiples go on forever. The factors have a set number. These are the only factors that exist. There are no more factors. All right, not so bad, right? I'm almost out of room on this page. We're going to come back to this page in just a second, but I want to do one more rainbow before we go on. So I'm on my next page. This is my 3rd example, and I'm going to do a rainbow for the number 7. So here's 7. I'm going to set up my rainbow. I stayed below the line. There we go. Let me see if I can fix that a little bit. A little bit easier to see. There we go. What would be the first fact in my rainbow cloud? We always start in the same place. We always start with 1 times 7. And 1 times 7 is 7. What about 2? 2 times 3 does not work. 2 times 4 is too big. All right, so 2 doesn't work. Let's go in order. We tried 1, we did 2, let's try 3. What about 3 times 2? That would be 6. What about 3 times 3? That would be 9. So 3 doesn't work. What about 4? 4 times 2 is 8. That's too big. What about 5? 5 times 1 is 5. 5 times 2 is 10. That's too big. What about 6? 6 times 1 is 6. 6 times 2 is 12. There's nothing else. So I'm going to put my cloud down here because guess what? These numbers are still the factors of 7. These are the factors. There aren't very many, are there? Not at all. Make sure you can see that. In fact, if I said how many factors are there? There are 2 factors. There is 1 factor pair. Now, I could still list multiples because what do we know about the multiples? On and on and on and on. Multiples go on forever. On and on and on. Never-ending multiples. So I could skip count by 7. When I hear multiples, I think skip count. Can I skip count by 7? Sure. 7 plus 7 is 14, plus 7 is 21, plus 7 is 28, plus 7 is 35, plus 7 is 42, plus 7 is 49, plus 7 is 56, and on and on and on and on and on and on. Multiples go on forever. The factors have a set amount. And how many factors did we have in this example? Only 2 factors, 1 in itself. So this number has a very special name. This is called a prime number. I'm going to write it inside my rainbow. A prime number only has 2 factors, 1 in itself, nothing else. I'm going to go back to the other page, which means all of these numbers, are these prime numbers or not prime? They are not prime because look at all these stripes. They have more factors. So I'm going to put a C inside those. These are called composite. We'll talk more about this tomorrow, but I just wanted to introduce the words today. These are composite numbers because there are more than 1 stripe in your rainbow. This is a composite number because there are 3 stripes in your rainbow. 7 was what we call a prime number because it only has 1 stripe in your rainbow. Let's try the number 9. All right, I'm going to make a rainbow for the number 9. What is the first place I should always put in my rainbow? What's the first number I always start with? 1 times 9. Very good. 1 times 9 is 9. 2 times anything, does that give me 9? 2 times 2, no. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. 2 doesn't work. Let's try 3. 3 times 3. 4 times anything? No. 5 times anything? No. Not 6 or 7 or 8. So this is it. The numbers in my cloud, these are the factors of 9. It's a set number. These are the only numbers that are the factors of 9. Up here, I could skip count by 9. And what are these called? These are the multiples. The multiples are like the stars in the sky. The multiples go on forever. 9 plus 9 is 18. Plus 9 is 27. Plus 9 is 36. Plus 9 is 45. Plus 9 is 54. And we could go on and on and on and on. Really what we're saying is this is 9 times 1, 9 times 2, 9 times 3, 9 times 4, 9 times 5, 9 times 6. The factors have a set number. The multiples go on forever. It's important to know the difference. Now, is 9 a prime or a composite number? So think about our rainbow. Does it have only one stripe? No. So we would put a C in our rainbow. This is a composite number. A composite number means that it has more than one set of factor pairs, more than one stripe. So I heard someone say all odd numbers will be prime. Well, look at what we just did, because we just proved that that was not true. 7 is an odd number, and it is prime. We can only do 1 times 7. But 9 is a composite number because I can do 1 times 9, and I can do 3 times 3. So let's practice just with a couple more odd numbers, because odd does not have anything to do with prime. We want to disprove that before we get confused. All right. So I'm going to draw 2 small rainbows down at the bottom, both with odd numbers. Let's start by making a chart so we know the difference between odd and even. If a number is odd, then it means that it doesn't have a match. Like 1 is odd because if I drew 1, there's not a partner for him. 3 is odd because if I lined them up, these two could have a partner, but this one does not. So we say 3 is odd, it doesn't have a match for everybody. 5 is odd because if I lined them up, these guys would have matches and these guys would have matches, but this guy is kind of like the odd man out. He doesn't have a match, so we call him an odd number. 1, 3, 5, 7, and 9. These are our odd numbers. 5, 6, 7. Because every time I try to find partners for everybody, there's always one person left out without a partner. Even with 9, it just doesn't work right? Look, this guy's all by himself. He doesn't have a partner. These are called odd numbers. 1, 3, 5, 7, and 9. If your number ends in a 1, 3, 5, 7, or 9, it is odd. Now, even numbers, they end in 2, 4, 6, 8, or 0. Because even numbers always end up with an equal partner. If I have 2, do they have partners? Yes. If I have 4, does everybody have a partner? Yes. If I have 6, does everybody end up with a partner? Yes. And of course, if I have 8, does everybody end up with a partner? Yes. So we call these even numbers because everybody has a partner. Any number that ends in 10, it could be 10, it could be 20, it could be 30, I could make it 80, I could make it 180. If it ends in a 0, then it's an even number. It means everybody would have a partner. So it's important to know if our numbers are odd or even. Even numbers all have a partner. So we're just talking about odd numbers for a second. Let's do 3 more odd numbers. I'm going to make them 2 small rainbows down here at the bottom. Make sure that you can see. Here we go. I would like to do a rainbow for the number 5. And I would like to do a rainbow for the number 15. And I picked these numbers because they're both odd. 5 and 15, they both end with a 5. They're both odd numbers. Well, let's think about our rainbow for 5. I would start with 1 times 5 because that's always my first fact. We need to go in order. We start with a 1. 1 times 5 is 5. 2 times anything? No. 3 times anything? No. 4 times anything? No. So guess what? These are the factors of 5. And since there's only one stripe in my rainbow, we call this number a prime number. There are no other matches for it. Now, of course, we could list multiples because multiples go on forever. 5, 10, 15, 20, 25, 30, 35, 40, and on and on and on. The multiples go on forever. But let's look at 15. 15, I always start at the beginning. 1 times 15. 2 times anything? No. 3 times 5 gives me 15. 4 times anything? No. And 5 is already there, so guess what? These are all of my factors. These are the factors of 15 in my cloud. There's a set number of factors. There are no more factors. But we could skip count by 15s all the way till I ran out of room in my notebook. 15 plus 15 is 30, plus 15 is 45, plus 15 is 60, and so on, because these are the multiples. And the multiples go on forever. Now, what letter should I put in here? Is this a prime number, meaning it only has one stripe, or is this a composite number, meaning it has 2 stripes or more? I'm going to put a C. This number is composite. There are more factors than just 1 times itself. And that's it for today. So go practice with your rainbows and do a nice job.